Thank you so much, Sridhar, for such an insightful session. So next up, our third speaker will be Sudhakar. He's a Chennai-based technologist and an independent consultant specializing in generative AI. He's also the co-founder of Tarka Labs, and his recent works include Vidura. Vidura is a production-ready knowledge agent. And yeah, so let's welcome Sudhakar on stage.
Hey everyone. So this is Sudhakar. I'm going to talk for the next 30 or 45 minutes about this building agentic AI with Agno. Just a quick show of hands reading the room. How many have already heard of this framework called Agno? Okay, no problem. There also, okay. So Agentic AI, yeah, pretty much, if you open the internet, if you see any of the social media channels, you will be hearing about this left, right, and center. So let us not, I'll not ask that question as how many of you know this whole agentic model at some level, at what level of understanding, that's okay. And how many are developers here, basically hands-on, do some development, do some coding work? I see some there. Okay, cool, fine. Okay, then I think you'll be able to resonate to what I'm going to talk and then what I'm going to show. Some of the examples also I have and demo as well. So without further ado, let me jump in. And yeah, again, feel free to maybe raise hands and ask questions if there is anything in the middle, or if you can hold on to that, that's also okay. You can ask at the end of it. But yes, this is me. So I've been building software, designing, architecting, for the past 23 odd years. But for the past 1.5 to 2 years, I've been mostly working on building AI-powered, Gen AI-powered especially, solutions for companies, startups, and also we have a product called Vidura, which is based off a RAG, Retrieval Augmented Generation. Now pretty much no one talks about any of that, but I'll explain the transition of how it started and why now everyone is talking, going gung-ho about this agentic models, agents will be replacing humans, blah, blah, right? I'll go in details of that as well. Okay, so what's the hype? Why suddenly everyone is interested in this agentic AI models, right? So if you wanted to get into the Gen AI space now, you are expected to know at some level what agentic models are, agentic AI is, right? But let me walk back a little bit so that we'll understand how we got here and what is that you should know to see that, to make sense out of this whole hype cycle that is happening. And it's very common, no? There is always this hype cycle in software tech. For the people who remember blockchain was so much hype that, oh, it's going to change the whole monetization ecosystem. Every money will be in a digital form and blah, blah, right? But that didn't happen. There are a lot of these hype cycles, but one thing is very clear. This generative AI is definitely a game changer in the sense, so it is very different from the other technology hype cycles that we saw. But again, like any technology, how you understand, how tech people understand it, how non-business understands it, there is a gap. So it will get to the point that, oh, AI is going to be so powerful, some assume, but it is not the case always. So AI agents are just LLMs, right, with a to-do list and attitude. That's how I put it. No, this is not, of course, a bookish definition or a technical definition of it, but this is how I see it after working with for so long, right? What I mean by that. So LLMs has been there for, let's say, easily 2.5 years. Everyone kind of started using LLMs. We are using it in the form of chatbots, right? You ask a question, you get a response, right? It's just a next token predictor, right? It's nothing more than that. And even no matter what we say, LLMs are very smart, powerful and all, its work is just to predict the next token for the given set of tokens. When I say token, you can think it of like a word, but there is a difference between word and token. I'll not get into the technicalities, but it's just a next token predictor, right? The more billion parameters you add to it, it might predict the next token with more probability. It's just a probability game, right? It is not a deterministic game, but it's a probabilistic game. But LLMs, you add something more to it. You wrap it in such a way that now you're calling it as agents, right? And what is that wrapper? It's basically what I'm trying to say it here. I'll go into the details of what I mean by that. Hey, how will you add an attitude to an LLM? How will you add a to-do list to an LLM? And then now, voila, you can call it as an agent, right? So this is what I mean by attitude. So LLMs has a way of thinking. So thinking is, I'm kind of using the word thinking here loosely. It's not like how humans think, right? But as I said, it is trying to predict the next token based on some way of prompting it, some way of tuning it, right? There we can control it, right? So the moment you are able to do the prompt engineering, nowadays they are not calling it as prompt tuning, right? It's like so 2024. In 2025, you should call it as context engineering. Pretty much it's the same, but you are put more bells and whistles to it, and you call it as something new. That's the only way that we can keep things cool, right? So, but context engineering is what you give to it, and then also you give more tools to it, right? In addition to LLM, of course, it will have access to an LLM, and you give goals and tools to it. I'll explain these things at a high level, what I mean by those, so that you can get a pretty good picture of all these things that are put together, and maybe you can go around and play experiment after the session. Okay, so this is what I've been talking about, right? It's the same as before agents, right? For example, last year, 2024, around this time, or even a couple of months before this last year, we already were talking a lot about RAG. Anyone heard of RAG? Building RAG applications, retrieval augmented generation. Even I did a workshop last year around this time saying that, hey, it's very easy to build a RAG, and we took 1 hour, 1.5 hours to build this RAG application from scratch. But now it's just single line. So in Agno, for example, if you wanted to enable RAG, give some knowledge to your agent, you just add a single line and then you connect a vector database, you're done. So that is the way things are wrapped. So all these abstractions are built over last year findings, so it's very easy for you to integrate them now. So on those lines, yes, so you can still say agents are nothing but hyped LLMs behind it. It's basically LLM is doing the heavy lifting at the end of the day, right? But it is also no in some aspect. Say, for example, whenever we were talking about LLMs last year, before all these agentic models, it was mostly about, hey, it's an answering bot. You ask a question, it'll give you an answer. It is knowledge. It has a lot of knowledge. You use that knowledge to make sense out of it. That is where it stopped. Now the next abstraction is you're building more over it, right? You are making it to act. So you are making it to act behalf of you or someone. So that is where the agent, the essence of agent that is different from what was before, right? If you are able to make it act on something, if you are able to make it take decisions, then you don't have an LLM chatbot anymore, you have an agent, right, at a very high level. So again, no, it is still an old way of doing to an extent. Why? Because they still wait for a trigger, meaning they are not totally autonomous. Good thing, no? So we don't have the Skynet problem yet, like what we saw in Terminator, maybe. But they still wait for a trigger. So it needs to be triggered in some fashion by a human sending a message or by some system calling it or in some way. But trigger is still mandatory. And now also, no, they do dynamic planning. So all these agents can do dynamic planning and they are goal directed. That is where, no, I'm just trying to put the differences and commonalities between what we are building as agents now and what we are building it as LLM-powered applications, right? Okay, so in summary, what is an agent? If you have all these ingredients in your LLM-powered application, then congratulations, you have built an agent, right? So what do you need? You need a long-term memory, that's the RAG, right? Think of it like you have huge documents and huge content, thousands of articles and all that. So obviously you cannot dump all of that in your prompt, right? Why? Anyone? Why cannot you dump hundreds and thousands of documents in your prompt? Context length, yeah. So the moment context length is no more a problem because every model that is getting built, they're trying to increase this context length, make it bigger and bigger, right? Maybe at some point in future, you don't need to worry about this RAG at all. You don't need to worry about any of this. Maybe it is so easy that LLMs can automatically learn, self-learn. Right now, you need to pass an LLM do tuning, build a next version, it's not continuously learning, right? So at some point we might not need it, but at this point in 2025 we would need it. So you need a RAG, some mechanism, some way of doing a retrieval augmented generation, and you give tools to it. It's similar to, think of tools like how we use tools, right? You have a screwdriver for something, you have a hammer for something. So you know when tool to use, what tool to use, when for what, right? The same way an LLM can decide what tool to use for what situation. Some of the tools, for example, I'll also explain some of the tools, but you give tools to it. And then, of course, no, there should be some memory, right? LLMs inherently does not have any memory. It's all stateless, right? If you make 1,000 requests to ChatGPT, every request is unique. It does not have any state. It does not understand or remember what is the before context or what you spoke before. So it should have some memory and also some reasoning. And then, of course, goal. So you are building it in such a way that it is going to achieve a goal. So this is all the different components that at this point you should be aware so that we can jump into Agno. Okay, so this is an open source framework. So please feel free to jump into this. If you even do a Google search or ChatGPT search, so you will find Agno library, which is in GitHub, and they're calling this as a reasoning agents framework. There are a lot of other libraries out there which are very similar, and I'm going to speak only about the open source that is available there, that you can build, that you can explore, that you can learn. That is where I usually have worked so far. So I'll, at the end of the presentation, the last slides, I'll also show the other libraries that you can use. But I like Agno for specific reasons. That is what I wanted to share here. I hope that I'll motivate some of you folks to also go and explore and contribute and evolve it, maybe. Okay, so what does Agno provide? Some of the things, okay, so one thing that I did not I failed to mention before during the start is, all this is based on my learnings building a couple of agentic solutions for customers. One of the customers is a startup, and the other customer is basically a product, mobile application product that they have. And we have integrated this agentic models into their systems. So based on that, we have used Agno even there. And based on that is what I'm trying to explain. So these are some of the abstractions that we have used and that I have seen clearly it's very beneficial and powerful, but there are more abstractions in Agno. So if you go to Agno documentation, which is very cleanly laid down, you'll be able to see more such abstractions, more such tools provided by the platform. But at a very high level, if you see memory, short-term and long-term, we have been talking about this even from the morning now, right? In one of the first sessions, I think he was explaining about the short-term and long-term memory. Prashant was explaining about that in brief. I'll also give a brief about that. And tools, and we have structured outputs. I'll come to what structured output is. I'll go in details about what structured output, why it is very important, and also the context and user control flows. It's the human in the loop. Yeah, so this is what we are going to see very quickly. Okay, so Agno, memory, right? So we have this two types of memory, short-term and long-term memory. And again, I don't want to repeat the same thing that Prashant repeated. You get the context, right? Short-term, long-term, like how we usually humans think. Some things that we forget, some things that we wanted to remember, we'll note it down. Right? Short-term memory, session memory, straightforward. As I said, every API call that you make is stateless. Every, even Claude, ChatGPT, whatever that, even DeepSeek, whatever that you pick, when you make a call, it is stateless. But stateless, you cannot build applications with stateless, right? You need state. So that is where session memory comes. And Agno gives a very simple, easy abstraction to make any of your agents stateless. You just give it a data source. It can be Postgres, it can be Redis, it can be any data source, and then we'll be able to connect to it and then start remembering all the session information. That is short-term memory. And in long-term, Agno has this constructs like user memory, session summaries, and RAG memory. As I was explaining about RAG memory, that's what pretty much I've explained, right? Or what RAG memory is. And session summaries is again, I mean, it's very evident from the wording itself. It will take the session, once it is completed, it will summarize it, and it will keep it in long-term memory, right? Similar to how we do. If you have a conversation with someone, we will not remember every statement that we made, but we will at least remember at a summary, hey, this is what we discussed, right? That will be useful when we come back to that specific context. That is where the session summaries are. And user memory is basically personalization. So right now, most of the agents that are built, most of the startups that are building these agentic models, the personalization is very important. So it will be able to differentiate every user, and then it will be able to remember the preferences of the user. And it will use that in the context to be a lot more intelligent, or at least respond intelligently, depending upon who the user it is speaking to. And then it will take that preferences, and then it will be able to respond appropriately. If you have seen ChatGPT recent versions as well, right? So that also has this user memory, and you can actually ask it to remember some of the things, and you can also tweak it or tune it in a way that it will be able to answer tailor-made. So that is what user memory is. And Agno is also giving a library or a framework or a class of sorts so that it makes it easy for you to plug in user memory to it, right? So yeah, this is at a high level the different memory modules that are present in Agno. And we are using pretty much all of this. User memory, not much, because that is the next version that we wanted to add. But all the other things we are using, and it is very effective and helpful for what we are trying to achieve. Okay. So this is with respect to the tools. So as I was telling, everything is a tool, right? Starting from a screwdriver all the way till a car, everything is a tool. We can see it in that way, because every tool is there to achieve something specific. That way, Agno is already having a very active library or community. So where these many people are building different tools, and then they are putting it open source so that others can use it. You can look at it like typical open source ecosystem. For example, DuckDuckGo, Google, Slack, Zoom. So the beauty of this is, if you wanted to say your agent to connect to Slack, say your agent wanted to take some actions and inform in Slack in some of your channels. I'm just giving an example, right? All you need to do is include that tool and give it the auth credentials, the key that it is needed for securely connecting to your Slack, and then it will be able to start work, right? As long as you can prompt tune it in such a way, it has a tool at its disposal and will be able to quickly connect to Slack. And also the same way with Zoom to start new calls and things like that. So I think the possibilities are endless, right? The moment you are able to get this thought process or the agent as a thinking mechanism, and then it is able to use these tools at your disposal to orchestrate, coordinate multiple things. It's like, if the IFTTT, if you have heard of this, if this, then that, there is this that you can connect. And also N8N is a new platform which is very popular, where you can connect multiple things and then make it work, create workflows and all. So you can do that at agent level with these tools. And writing your own tool is also pretty cool. So these are some of the things that I really liked in Agnos, because it gets out of the way. So, I mean, I've worked with Java for quite some time during my early years. The thing I hate with Java, sorry for all the folks who are into Java, but it gets in the way too much, right? Say, for example, it will make you to create factories and factories for factories, and you have patterns to create the right way of factories. It's too much. But Agno especially does this very nicely, saying that, hey, I'll get out of the way. Say, for example, if you wanted to create a tool, all I want is write a Python function. Not even, you don't need to annotate it. You write a function and you write docstring to it, like how we write a docstring for all the Python developers who know. We just write a documentation of what this function does, what parameters it takes, what it is supposed to do, what it is returning, that's all. Given that these LLMs are very good with language, human language, it can use that and then decide which tool to call based on the given context. So that is with respect to writing your own tools. I'll show some of the examples for the custom tools that we have built. The beauty is, you'll see that it's like 10-line code, but it does a lot more than the size of what it takes to build them. Okay. So structured output. What do I mean by structured output? So in any of the LLMs, when you make a call, what you get back is a string, text at the end of the day, right? No matter how you prompt it to say, for example, whoever has fought with this non-predictable nature of LLMs, you will resonate with me. You cannot make it comply to your request 100% of the time. That's the toughest challenge, right? Why? Because of, so even you set the temperature, you set top P, top K, you set all these values, you cannot say 100% that this is what you'll expect back. Why? Because that is the nature of an LLM. That is what makes it powerful, right? It'll be able to innovatively change its output with probabilistic nature. The problem with that is, say for example, if you're building an agent, and that agent's output is going to be processed downstream by some other system, right? At that time, the system expects a very clear JSON object. If your agent is not able to give a JSON object 100% always, then think about the way how you can plug this in your existing flows. It's going to be impossible, right? So that is where the structured outputs come into picture. And one quick note, not all LLMs support structured output. Be it tool calling, be it structured output, so many of these features that I'm explaining, you have to check with the LLM model as what it supports. All right, so usually the small models like 2 billion parameters or 7 billion parameter models, they are not very good in supporting some of these features, but some do. So they are fine-tuned for the specific cases. You just need to check what it supports and then you use it. But most of the big models, they are very good in supporting this structured output. So the idea is this. You give a pedantic, a model to it, a definition. Basically, if you see there, the definition is, where is that? Yeah. So basically, I'm giving a definition here saying that there is a movie script, and then the movie script class is supposed to have only settings, endings, genre, name, characters, and storyline. That's all, right? So if I'm able to define a typical model, and pretty much in programming, that's what we do, right? We define a model and we fill it and we send it as a response. So you define a model and you give it to the agent using Agno, then you are guaranteed 100% that when you call an agent, its response will always be aligned, or it will be actually, you can cast that string to this model, blindly. You will get that model, right? Maybe it will not fill all the data, depending upon the current context. It might not have all the data, but you can make it optional. You can define it in such a way that what you can expect is what you will get. So that makes it very powerful to plug any of these agents into your existing workflows or existing whole process definitions and all that. Yeah. Okay. I think the presentation got stuck with structured output. There's no structure to the output here. Okay, it's working. Okay, so yeah, that is with the structured output. And context. So context is the king, right, when it comes to prompting. But when I'm talking about context, it is a little bit different, right? So when I say context here, in the context of Agno at least, it is not like what you put inside the prompt. Usually, your prompt will have different parts of it, right? Here you will have a setup, you will have a definition of what this agent is, and you will also say, hey, I'm expecting all this. You'll also say, don't do this, don't do this. You will write so many things for the people who are playing around with LLMs and prompting, right? Mostly, almost always, when you're building agents which take decisions like this, it needs information on demand, meaning, say, for example, current date and time, right? For every call, you need the current time in seconds to the seconds level, depending upon your use case. Or say, for example, if you need the information from calling some other API to augment your prompt, right? You still can do that. Basically, you can make a function call, and then you get the results, and then you'll have a string, huge string with variables, and you replace that string with values. You still could do that, but this context definition makes it very easy for you to set this. So if you see this line here, all I'm saying is I'm creating an agent, and then I'm saying context is, and then you have a key and a value. This value is basically a function that will call. So before it makes a call to an LLM, it executes this function, and it gets the results, and then it'll put in the context. And then this goes to the LLM call. But fundamentally, so remember this basic idea, right? So anything that you do in Agno or any of these frameworks like DSPY, there are so many frameworks like this. At the end of the day, your LLM API call will see only one string. It's just one string. It does not know anything else. It does not take anything else. Maybe function calling, if you're defining functions, yes, it will take some of those things. But mostly all this information gets into this one huge string that the LLM is supposed to parse, understand, and then respond back as a string, right? So all these things will get into that string. Just that if you use context and things like this, it is easy for us to organize our code and keep the code maintainable and reason out the code and extend it and evolve it. So that is where all this help. Yeah, so real-time data, it keeps the context fresh and no prompt strings patching. And the context is dynamic dependency injection. So that is the high-level idea where you wanted to use context instead of always using strings and mashing up strings together to pass it to LLMs. And yeah, the last one in some of the features that I'm trying to explain in Agno is this user control flows. As I said, agents still needs a trigger, and also sometimes it is better for some of the critical functions and operations. For example, say there is this decision making that are sensitive. So there is some sensitive decisions that you're making. Your agent, you're trying to make an agent to do, say, send a mail. It could be a simple decision, but say, for example, trigger an action or doing a purchase on its own. All those things, you can have an agent in a human in the loop so that it will ask for a confirmation from the user. It could be in any way. Again, right, you could have a simple tool, Slack integration, and then a user will get a notification in their Slack saying that, hey, this is what I'm going to do. Are you okay? And this is the context. And it could have a couple of buttons in the Slack, and then you click on S, and then it continues from there. Your agent will continue from your input, whether yes or no is given by a user. So that way you can build workflows where a human can be present, and then he will give a go-ahead so that the agent can continue what it's supposed to do or what it's planning to do. This is very helpful for even costly operations. Some of the operations could be like, for example, purchasing decisions, it could be, or even spawning a new instance, right? So creating, if you're automating your infrastructure management of sorts, so creating new GPU instances could be costly. Say if you create one A100 and then it's going to be costly and all that. For all those things, a human in the loop can be very useful. And it also can be used as a tiebreaker, right? So say the moment, okay, we got to the state where we started creating multiple agents, and then I'll also briefly explain about that. The moment you put all these multiple agents together and you create a team of agents, now it'll get a lot more fun. I mean, because now they will start talking among themselves so much that now the response times are shooting up. Whatever we are able to get response for 5 seconds, now it is taking 25, 30 seconds. Because why? The agents are so busy talking to each other, and they don't know what to make a decision out of, and then it is delaying the whole process of now this whole end-to-end response times and all that. So maybe during those times, it also might be a good idea for us to have a human in the middle and say, hey, I'll do the tie breaking, don't do this, proceed. And the beauty is if you are able to design your system properly, it can remember this decision and it can use it the next time, things like that. So I think it can continuously be also learning and evolving. So that is with respect to the user control flows. Okay, so before I jump into what we build for field technicians, so this is what at a high level, okay, we have time. At a high level, I wanted to cover at the Agno level. Any questions, we can take a quick pause or we can proceed. If there's anything that is burning that you really wanted to clarify, because all the things that we saw so far, I'll go deeper in showing them, saying that, hey, this is how we use this is how we use this, and this is how the context is, and this is where the things are. I'll also show some code, right? It is not just only a presentation. I'll also show a quick demo. I hope demo guards are with me this time, so that I'll be able to show a demo. If not, I'll also play some videos so that you'll get an idea of what an agent can do, right? So any quick questions or we'll move?
Yeah, I have a question.
Sorry, yeah.
If agent's communication is streamlined, then tiebreaker is not needed, right? Human intervention is not needed, right?
Correct.
So how to streamline the agent communication?
So the idea of agents at a high level is this, right? So if you are able to define a clear workflow, like a flow chart, hey, do this, do this, do this, do this, then you don't need an agent actually, right? Because you have already defined what needs to be done. So there is no dynamism for an agent to decide, right? So the agent as a concept comes only if the decision should be dynamic depending upon the different parameters that is coming in. So if we have already streamlined the workflow, we ideally don't need an agent. What we can do there is for the parts which need this dynamism, where an LLM can help, just create a tool as just a simple service that will use LLM and then tools, and then just get the thing done. So ideally, we don't need an agent for almost all of these scenarios if we know clearly what needs to be done. So that is how the pattern that we have seen.
Can we have an agent for the tiebreaker, to break the tiebreaker?
Yes, we could, but the point is the whole idea of tiebreaker to have a human is so that we will have some control, right? As I said, right, we actually experimented. We had 4 agents running in wild. They were going crazy, right? Because each one is going to say that this is what I found, and the other agent will take that and will try to build over it. At the end of the day, there are LLMs with context, right? So sometimes, yes, you could even have a tiebreaker agent. No, that's definitely there. But sometimes we saw a human intervention is needed clearly, then it is easier to have this human in the loop.
Okay, fine.
Yeah.
Thanks.
I think someone has a, sorry, yeah. Maybe after that question we'll proceed, because whenever I think it's like project execution, right? Whenever we think that there is enough time, we will burn all the time and then we'll not have time for completing it.
So I have a question on structured output parsing.
Sure.
So we often shift models for multiple use cases. So how to build systems to support structured output for multiple models? Should we need to again and again refine the code basis to make sure the code works for multiple models if we are doing this structured parsing when we get responses from LLM? So that's one. And I have another question, which is like how to use frameworks like Pydantic for inside platforms like Salesforce. So we are not building AI native applications, but we are trying to build AI applications on top of existing platforms like Salesforce to use it for our business use cases, but we are struggling with this structured parsing. But I can definitely correlate to what you spoke, because we face this a lot when we build applications. So if you can give some light, that would be helpful.
True, true. I'll briefly go over this and we can also discuss after this. The brief definition is, for your first question, if you switch models, everything is out of the game. You have to do the testing all along. I'll show some of the techniques that we are using for testing automation. Automated testing we are also doing. But the moment you switch models, not even going from one major model to other major model, if you go from version to next version, then I mean, all your bets are off. Whatever that used to work before, there is no guarantee that will work now. It will not respond the same way, right? So on that aspect, you pick a model which is already supporting structured output is the best bet. So if you are trying to take a very small model, if you're going to fine tune it so that it can respond in structured output, the biggest challenge with that is you should have that huge data set. See, structured output at the end of the day, it is able to, some of the models are able to give structured output. Why? Because of the training data that it has seen a lot of the structured outputs. It just boiled down to that, right? Nothing else. So now you are picking a model which is not already trained to give structured outputs, then all that burden is on you. So now you have to create huge volumes of structured output. You say that, hey, this is the question, this is the structured output that I want, and then you make it. You basically are changing the biases and weights of the neural network so that it can probabilistically give you structured output without breaking the structure. That's for the first one. Second one, I did not get the whole context, but what we have seen is, if you wanted to integrate any of this LLM benefits, dynamism, into your existing systems, it is better always to go to build them as separate services and plug them in. So from the bigger picture, it is just yet another service. Whether it is behind an LLM, it is an agent, or it is using an LLM, doesn't matter. So that is what the structured output was able to give to us, right? So now it's a nice abstraction. It will get the job done, you will get the structured output back. It doesn't matter what it is powering that. But we can discuss in details also, yeah? Okay, so a bit of brief as what we did for this action bot, so that you will have a context when I show some of the demos and when I go to, showing some of the API calls and responses and all that. So we have an application for field technicians. So who are field technicians? You take any huge manufacturing plants or oil refineries or any of these huge cement manufacturing plants and things like that. They'll have huge equipments. They'll have lots of equipments that needs to run continuously. They will have this maintenance cycles. So say if something breaks down, it has to be addressed, right? That's going to be lots of things that will break down. There'll be a lot of things that needs to be continuously overhauled, maintained, and all that. So the technicians are the people who will be on the ground, who will be given work orders or tasks that needs to be done. And they take the work orders, and then they actually try to fix that, update the information. So basically, they are the maintenance people, right, on the ground. Like how we maintain software, they maintain the real hardware that runs the world, kind of, right? So those technicians, one of our products is basically a mobile application for them, so that they can be in mobility. It supports offline and all those features. So what happens is a technician just needs to have their phone, and then the application will show what are all the open work orders for them that they need to work on in a day. And then it will also show how to reach them. It will have maps, navigation, blah, blah, all that. But if they go there, they'll be able to open the work order, see the details, work on it, add log entries, or add a time that they've worked on, also escalate issues, all the usual rigmarole of maintaining any system or any hardware, right? So all that supported in this application. And we did not decide to add agents so that we'll sound cool in marketing campaigns. I think that is also one of the reasons, I don't know. But the main reason that we wanted to make an agentic voice-based addition to this product is because most of these technicians working on these things will have gloves and all that, right? So it is very hard for them to keep on entering the information for what they're working on, because their prime role is not to update the data, right? Their prime role is to fix things, and updating the data is just a mandatory imposed on them, right? So we were trying to see how can we make it easy for them to do this, and that is where we enabled this voice-based integration. So all they now need to do is click on the voice button, similar to what you have seen recently, Gemma. If you have seen Gemma 3N demos, right, where that's pretty much what even Google is trying to build, right? You click on a button, you explain to it, it'll do that. Hey, book an Uber, and then it'll be able to do all the different actions inside, and then it'll be able to execute it, right? On the same lines, we have a much smaller scope, right? We know all the features that is there in our mobile application, and it is built inside the mobile application, where you click on the voice button, and then you say what needs to be done. Say, for example, hey, open this work order. And then it knows how to open a work order because of all the different components that we have put. I'll show a high-level architecture, not very detailed, and you will not have a lot of boxes with little text, but that's okay. I wanted to always keep things simple so that I can drive the point home. So yes, it will have this voice-based activation. You give a voice message, and then it will perform. Done. But also it will ask for confirmation before performing, and then it will perform that action. Yeah, that is at very high level, action bot, what it is supposed to do. And yeah, this is the higher level architecture, right? Yeah. So you have the technician, and then he has his mobile phone. Yeah, it doesn't look much like a mobile phone, but yes, assume that it's a mobile phone. And then he will talk to the mobile application. And inside the mobile itself, mostly Android, iOS, all these devices have a built-in voice synthesis, speech synthesis and voice to text modules. You don't need to even go to the internet for this. So it will convert that voice to text. And the moment we are in the text land, we can pretty much do everything, right? Because we already have this very powerful LLMs and all this that can understand text better. Even though now the multimodal LLMs are getting very popular, starting with ChatGPT, where it is good with voice and audio, they are very resource intensive, meaning you should have a very good bandwidth, and they're very costly and all that. So we didn't take that approach. Instead, we are converting the voice to text inside the device itself. After converting that to text, we are going to call our agent to understand the user message so that it can find the right action to perform. So finding the right action to perform itself is actually a challenge on its own. I'll explain why. And then once it is able to find the right action to perform, using its tools at disposal, right? Context, memory, tools, it will use all of that, ideas that I've explained so far. And then it will respond back a structured output. And the mobile application, once it is able to get a structured output, it knows very well has what needs to be done, because the structured output will say what action to perform, what are the parameters, and what is the next action to perform, and all that. It basically makes it very straightforward and structured way, so that the mobile application now execute all of that. And we already have offline capabilities to the mobile application, so it was very easy for us to connect all these things, so that once we get the structured output, we'll plug it in. And we are able to build this whole end-to-end in 3 weeks' time, and then we are able to get it to our customers for first beta testing. So now they are experimenting with it, they are getting us feedback and all that. But the point I'm trying to make is, once we get this high-level design in place in a lean fashion, building agents should be very fast. And if we are able to build it with, like in an iterative fashion, like how agile development says, right? Build iteratively, get the user feedback, and try to improvise on what is working and what is not working. So that is the high-level architecture. Okay, let me give it a shot. I'll show a quick demo. And I hope that it'll work. There is internet. Yeah, okay. And I'll show first how the application looks so that you'll get a feel. Oh, okay, it does not switch here. Okay, wait, I know why. Okay, you're able to see, right? So this is at a very high level how you see the applications when you're running it. So you're asking different questions, right? Hey, no, update the work order number, and then it says whatever that it is talking, whatever that it is voicing back, it will also print it on the screen, so that no, you have this two modalities where you can see it, and we'll also listen to it. Say for example, when you're not able to listen to it, also you can type it as well. So it's like voice or text-based, but it's pretty much the same effect, right? So this is how the conversations will be. It's very simple, straightforward, lean at this point. Yeah, it all looks white, but there is some light coloring there as well. And then you have this interaction happening. So when you look at this point, it looks like any other chatbot, right? But it is also performing actions on behalf of the user. So it is also doing actions, and then it is giving acknowledgements and confirmations. That I'll also show a quick video.
Hey, Tammy.
Hey, technician. How may I help you?
What are all the work I have related to inspection?
So all this voice to text conversion is happening inside the device. And yeah, it is slow. We'll now get to that.
Inspection-related work orders.
So now what it is. So the question was, what are all the things related to the pump?
You have 3 work orders related to pumps.
So this is just a starting. So you're asking for specific work orders, but the next thing you will do is, hey, you'll say, open this work order, because you know what work order that are there. The moment you open the work order, then you can give more commands to it, saying that, hey, now add a log entry. Oh, I worked for 6 hours yesterday. Just record that and things like that. Or close this work order, and multiple actions that you can give to it. Right? So I'll show a quick demo of the agentic part alone, without going into the whole technicalities of running the mobile application and trying to show end-to-end, but you get the idea. All right? How small or how bad it is to see? Pretty bad. Okay, let us try. So, for example, I'll take an example of this find work order, right? So if you see from an API level, so the agent now is working as an API, that's it. Be it mobile application, be it web application, be it anything, it doesn't matter. As long as you're able to make a call to this API, you get a structured response back, you're done, right? So how it is powering, it doesn't matter for you to plug it in. That is the idea in which it is built, right? So this is a structure, obviously. API, you will have a form body, right? That this is what you are expecting. And here what we are doing is we are passing a user message, and we are also having a context. Context you can pass a lot of information. The mobile application will pass all this information, saying that, hey, these are all the different work orders the user has, this is the current open work order, this is the date time, whatever it is, all the contextual information that will be used by the LLM to decide the right action, right? And then you pass that, and the user message is just this, right? It says, hey, open anti-rust coating work order, right? Because that user has already worked on something related to this. He knows the context. So he's just asking this question. And Agno also has a very nice way to look at all the debug information, as how much tokens, what is the input, what is the output, and all that. But I'll maybe briefly show what all the different things it gives you information for you to quickly develop and debug. But if you see here, it is asking for a confirmation, right? It is asking, hey, confirm. You're able to read through that. Yeah, so this is the structure output, right? I can always guarantee 100% that this API will always give me the output in this format. It will always have action to perform key, and action to perform key will have a name key inside it, and then it will also have the voiceover. That is what will be used by the mobile application to play it as a voice or convert it, speech synthesis, and it will convert this to voice, and it will also have a message to display. So you can have difference. You can play something with a very brief as a voice, and then you have detailed information in the screen. So this structure is confirmed, and then based on this structure, the mobile application will decide what is the next step to do. So if you see here, the name is confirmed. So the LLM is, the agent is saying back that, hey, I think I figured out what needs to be done here, but let me confirm with the user before I take that action. That is how we have also prompted it, or we have designed it, right? So it is saying that, okay, get a confirmation from the user, right? And then say now I'm saying that, yes, please go ahead. So this usually will be spoken by the user, but I'm just showing the textual side. So when I say yes, please go ahead. And by the way, it has the context, right? The context is here. So the session ID is one which will connect all these different requests so that multiple users, even if they're using it concurrently, it will not get mixed up because of the session. And if you see the response, yes, again you have an action to perform. But this time, there is a very well-defined action called open_WO. It's basically open work order, which the mobile application or the consumer of the service will understand. And then it will use that to do the appropriate actions deterministically, right? And then it also gives the parameters saying that, hey, if you wanted to open a work order, of course, you should know what work order to open, right? And then these parameters also well-defined using the Pydantic models. These models will define, say, if you get an open WO, the parameters will be these 3, these 4, whatever it is. That way, your mobile applications can build over this and then use it deterministically. Yeah, so you got this, and then there's also a voice over message and the message, right? So it says opening the work order for antitrust coding now. That's it. It'll just play that voice, and then using this action to perform information, the mobile application will do all the necessary things, and in the UI, you will see the work order getting opened, right? So far, so good, the flow. Yeah, so this is at a high level, and there are multiple things that we can do with this. Say adding log entry, updating labor time, pretty much it's the same time. It's the same idea. Say, for example, if I'm saying add labor time, I work for 7 hours a day, and then it will give you a follow-up question. So pretty much that is there, but it will run the same thing and it will tell you. Not exactly the same text, but it will always give you action to perform as a follow-up. Yeah, so it will say, hey, I need a follow-up from the user. Why? Because the user is saying add labor time. I understand that. I also understand that, hey, the user has worked for 7 hours a day, but the definition or what needs to be done to add a labor time that is very well defined is it needs start time, start date, end time, end date. Since it did not get that, the agent is coming back and saying that, hey, get more information from the user. I cannot perform this action, or I cannot even say you how to perform this action without this context, right? So that is where this conversation is happening. You could also think of this as no, I think this is not human in the loop, but because it's basically human interaction. So it goes back and forth till that goal is achieved. The goal is adding labor time or creating an action to add labor time for the mobile application. Yeah, so that is at a high level for different actions that we have. Okay, so that is with the demo, small quick demo that I had, and nothing broke and everything at least worked for me to show the thing in action. Okay, so these are the screenshots. And yeah, I can quickly show the code as well. Yeah, I think this will tie all the different pieces that we saw so far together, right? I was talking about this Agno has different blah, blah abstractions, and I was able to show a demo. And then I'll show quickly the code as well. And then once I look at the code, and then I'll quickly talk about some of the learnings that we had. And I'll wrap it. I understand now it's already 1:30. I'm sure that yeah, you all are hungry. Bear with me for maybe 5 more minutes, and then I'll quickly go over this, and then we'll have good food, hopefully. So for the people who have already built these agents and all this LLM-powered applications, almost half of your code will be just strings, right? More strings concatenated to have more strings for the LLM to understand, right? So that is how it will be, right? For example, I have an agent team, but it is a single agent now, and all the list of actions that it can do, and I'm giving all these details for the LLM to understand and make the right decisions and all. And creating an agent in Agno is only this, that's it, right? And almost half of this is even not needed, but that's all. You write this 10, 20 lines or 15 lines, done, you will have an agent. But the problem or the trick is not this writing 20 lines, but what to put where. So each and every variable will have too much of impact in the outcomes, and it also gets into very predictable range, unpredictable zones. All right, I'll tell you how we are able to tame that predictability of running an agent or building an agent by creating some automation test suite and all that. But at high level, I'll go quickly walk over this, right? Agno already gives you these constructs. Hey, you can give a name, you can give a description, and then you can also define the tools that it can use, right? So if you see the way that we have structured here is, there are different tools for different actions that I was explaining, right? So there is a tool that very specifically looks at, hey, if the action is to open a work order or find a work order, what are all the parameters that I need to build from the user context? And if it is not there, how will I go and ask for a follow-up? And the same way for log entry, and the same way for labor time and all that, right? And right now we are using GPT-4o. We have not started exploring GPT-5 yet. Hey, anyone started playing around with GPT-5? That was released, what, 12, 15 hours, 20 hours before, I don't know. That is like very long in no, LLM world nowadays, unfortunately. Is it any good or any, I think it's just an improvement of what we have now, right? Or maybe, okay, we'll discuss about this later. Sorry, I'm getting carried away by all the tech stuff, but yeah. So we have this GPT-4o, and then we have some parameters that we can set and all that. And then also we have a storage configured here. This is all it takes actually for you to plug in a storage for it. So there are this libraries already available or functions already available for SQLite, for Postgres, for Redis and all from Agno itself. So if you see here, agno.storage, there is a package that will give you all these different libraries for it. And then you plug it in and then you say, hey, SQLite, this is the file that you need to store. And I'm using this for session. So I'm saying that, hey, you store all the user session information in this. Why it is useful for me to create session summaries and all that. I can also even look up, I can use that for analytics, understanding of user patterns, usage and all that, right? And then there are also some other controls here. Say add history to messages, because this is what makes it remember, and it will give you the stickiness, right, as what was discussed the last time and all that for the conversations. A number of history runs, these are all like all this. You can find some 20, 30 parameters like this that you can understand and play around and set it up in documentation, which is very clean and straightforward. And there are a lot of examples given in Agno itself, so that you can look at that examples, right? And one other thing I wanted to show you quickly, not so quick, sorry. Let us take one example, right? So the action finder. See, action finder is basically what action to find. We have an action finder, or I'll pick something simple. Finding the work order, right? Finding the work order, I said it's a tool, right? But a tool can be just a simple function, right? So this is the function that I created, that's all. I exported this function, I used it here as a tool. Where is it? Yeah, so it's just a function, as I said, right? This function, what it can do inside is immaterial to the caller. And if you notice here, what I did is, this tool in turn again calls or has an agent, a sub-agent, right? That will make another LLM call when the tool is called. So now we have a hierarchy of agents. This is one architecture or one way of setting things up. Instead of having everything in coordinated mode, you can have an hierarchy, right? So there are multiple patterns that we are also exploring to understand which works well. But we have noticed this hierarchy is working very well for this use case. And that's what we have put it in or actionized and productionized it. Right? So each tool can do multitude of things. And for example, a tool can also have a team of agents to do this coordination and decide and respond back, right? So the abstraction, like it's infinite, right? You can go limitless and you can think of different ways of abstracting and connecting different pieces together, right? This is the way that we notice working very well for this use case at least. Yeah. So these are some of the things that I wanted to quickly show. And also the tests, I show what we did for tests. Because as I said, anything with LLM, it's hard, very hard to give a predictable, oh, it worked in this build, next build it didn't work. No one knows why, right? It's kind of, that situation is where we get into the moment we start building anything that is non-deterministic like LLMs powered, right? So what we did, we have this very simple structure where I have what headers to be passed, what is the sequence that I'm expecting, input, expect, output. So it will continue. So I can say multiple things, right? So for example, I'll show an example of a sequence that I'm expecting. Yeah, so here, this is the sequence, right? So when a user is making this call, when I'll pass this input message, I'm expecting a confirmation. And then I'll pass this input message, go ahead, and then I'm expecting this confirmation. So we have just defined this. The moment we define something like a JSON, you can have 100 use cases, it doesn't matter. And then we'll run this test API file. All it does is, it reads it, make an API call, and expects the response. And then it will do a fuzzy match of responses. For example, if you do an exact string comparison, you're dead, because you will not get the same string every time, right, from LLM. So do a fuzzy match. And what is the best way to do a fuzzy match? Vectorize it, and then do a vector similarity search. You're done. So you take the expected, you take the actual, you find the embeddings for it using any of these embedding models, and then you see how close they are. And you have some margin saying that, hey, if they are close 95% and above, then okay, you could safely assume that the test case is successful. Again, no 100% guarantees there. But this is one way that we are able to see that we are able to automate the testing, right? Because whenever we make a change, we cannot wait for 3-4 days for the QA team to jump in and test every question and see the answer and all. It's very hard. It's not going to scale. So this is something that we are exploring and we are trying to evolve it as well. And hopefully we'll get to some state sooner. So this is what we are doing with respect to the testing side of things. Yeah, it's already, it's time up. Who's time up? Sorry? Sorry? Logging? Oh, okay. So this is an API. So API, like any other typical API, we have a token, access token. So if you have a right access token, then it will work. So the access key, right? So because this is between systems, right? A mobile application securely installed in a mobile phone is actually making a call to this service. As long as it has a valid access key and it is able to renew that access key at a regular intervals, we are good. So that is where we are, there is no login per se. Okay, the run logs, okay. Yeah. So if you run this, it will just show, because it's basically any unit test, like any unit test, right? For example, if you see here, I'm doing an assert. So what I'm asserting is basically the actual value and then the expected value. So when you run a test, what you see is actually what you see here as well. I can try to run it. Okay, maybe we'll take this because of the time, but the idea is this. You think of this like any other API, and then if it is an API, what will you do to run automation test over it? Yeah, so, yeah, okay, and I think one thing that I really wanted to highlight, other frameworks I was talking about, right, DSPY, LangGraph, Crew AI, Llama Index agents, OpenSwarm, you can look at any of this. Pretty much everyone is giving this nice constructs, but what I like is OpenSwarm, OpenAI Swarm is trying to replicate a lot of Agno's success, like how Agno is simple, how is able to get the thing, some of the ideas right. OpenAI Swarm is trying to replicate that, so which is a good validation. And DSPY is also one other interesting framework that you can explore. Right, it gives you a lot more control with the controls and flows, right? So some of our team members are behind the DSPY. Say, for example, if you have invited them for this talk, they would have said that DSPY is the way to go, and then he would have explained a lot more about DSPY. So there are some camps like how React versus Vue. There's always these discussions. The same way that is also happening here. But yes, it's always good. It's healthy. That way we can compare and contrast and see what frameworks are working for what cases. So these are some of the things. And yeah, so for example, the learnings that we saw. I wanted to highlight only one thing in the learnings. Keep an eye on your LLM service builds, right? The moment you put these agents in production and then you run them wild, we found one thing by burning 100x of our usual burn rate, because as I said, the LLMs became very chatty, the agents became very chatty and they never stopped. There is no circuit breaker and there is no stopping. So one request triggered all these agents to talk so much that they were continuously talking for 5 hours without any response, right? But the response timed out, so the tester moved on with that, but at the background, the process is still running, and then it just burned the whole, and then we noticed by alerts saying that OpenAI started alerting us saying that, hey, by the way, your funds are running low, and it's like, then we noticed, oh shit, okay, fix that first and then release, and things like that happen. So that is something that you need to watch out for. And user training is also a very interesting thing that happened. Say, for example, we made this voice-enabled agent, right, or an application. The users were still talking it like how you talk to a bot. Say, for example, work log, open. So they were not trying to make full conversations with it. So with LLMs, if you're able to make a human-like conversation, the chances of you getting the responses is higher, because then it will have a lot more context of what you're trying to say other than giving keywords. So that is something we are still trying to figure out and fight how to make them understand that, hey, talk to this like a human, not like a, like what was before, right? Before technology, you have to identify the keywords and the keywords will trigger something. They are still stuck in that mindset. So that is something that we are also trying to enable with training. And so that is pretty much. So yeah, I'll stop here because if you let me, I'll talk about all of this for so much time, but yeah. Okay, that's it. And thanks a lot and if there is any time left, sorry about that, maybe we can take questions or we can even sync up during lunch. Yeah, thank you.